In this lesson, we're going to cover some of the methods used in securing network communications. Now, as cyber threats continue to evolve, it's always important that you learn about the different tools and protocols that are used to protect our data as it's transiting across the internet and other insecure networks. As we attempt to secure our data in transit, we have to protect it against any potential eavesdroppers or malicious actors so that our data communications remain confidential and trustworthy. To achieve this kind of data in transit security, we usually are going to rely on three main technologies. These are virtual private networks, known as VPNs, transport layer security, known as TLS, and Internet Protocol Security, known as IPsec. Let's take a look at each of these. First, we have virtual private networks. Now, a virtual private network, or VPN, is going to be used to extend a private network across a public network to allow users to send and receive data across a shared or public network as if their computing devices were directly connected to your organization's own private network. With a VPN, your users can work in a remote office or work from home and telecommute simply by logging into their laptop and establishing a secure VPN tunnel within their organization's network, regardless of where it is in the world. Now, to do this, users are going to connect to a VPN device sitting at the headquarters data center, and then they'll establish a secure tunnel using a VPN protocol in order to allow a secure connection from the corporate user's device over that untrusted or public network, such as the internet, back into the trusted network that is contained inside of your headquarters data center. These VPNs can be configured as a site-to-site VPN, a client-to-site VPN, or a clientless VPN. Now, a site-to-site VPN is going to be used to interconnect two sites and provide an inexpensive alternative to a dedicated leased line. For example, let's pretend that I have a branch office in California and my headquarters sits in Washington, D.C. If I want to be able to connect my remote regional office in California all the way back to my head office in Washington, D.C., I could buy a dedicated leased fiber line from a telecommunications provider that gives me a direct connection that covers over 3,000 miles between these two sites. Now, even if I got a low-speed T1 connection, this would be very expensive for me to use. So, I can actually use a site-to-site VPN instead, and I'll be able to save a lot of money. Instead of using a dedicated lease line, I can simply create a VPN tunnel from the regional office all the way back to my headquarters over the public internet using the internet connectivity that I already have in place at both of those offices. This solution might only cost me $50 or $100 per month using a standard cable modem or fiber optic modem from your local service provider at each of those locations. Now, once the VPN tunnel is established, it's going to take all the traffic from my regional office over in California and route it back to the headquarters in Washington, D.C. over the internet within this securely encrypted tunnel. And then once it reaches back to my network in Washington, D.C., I can decrypt that data and use it as if somebody was sitting right there inside the Washington, D.C. office. Now, whenever a California user, though, wants to go to google.com, their data is actually going to go from California to Washington, D.C., and then out the Washington, D.C. office's internet connection to visit that website, in this case, google.com, and then it returns that response back to the Washington, D.C. office, and then it goes back through the VPN connection over to the user in California. This way, we're actually funneling everything through that headquarters network. Now, this gives us an ability to have a lot of security there, but it also does slow down things for that California user because they have all this extra data transit happening going from the West Coast to the East Coast out to the website, and then back from the East Coast over to our user on the West Coast. Under this kind of a setup, we're really using a site-to-site VPN, and all of our traffic from California is going over to Washington, D.C. first before it goes out into the public internet. By doing this, all the traffic between those two sites is going to be encrypted and secure so that nobody can see our internal network traffic, even though we're doing all this over an external public internet connection. Now, when we deal with a client-to-site VPN, on the other hand, we're going to be sending data from a single host, like a laptop, a cell phone, a smartphone, or a tablet, and connecting it directly back to our headquarters office. This way, instead of going from a site's router to the headquarters router, we're just going from our device back to the headquarters. This allows the remote user to be able to connect back to the head office, and that's why we call this a client-to-site VPN. For example, let me show you how easy it is for a user to configure a client-to-site VPN from their Windows laptop back to their corporate network using their wireless connection. In this demonstration, I'm going to show you how to create a VPN connection on a Windows machine. Now, for this example, I'm going to use a Windows 7 machine, but it's pretty much the same process in any version of Windows. What we're going to do is I'm going to click on this wireless network that's currently connected, and I'm going to go to Open Network and Sharing Center. Now, from here, we're going to go to Set up a new connection or network, and this will bring up our dialog box to create our VPN. We want to use Connect to a Workplace, which is going to set up our dial-up or VPN connection. We'll then hit Next, And then from here, we're going to either use it over the internet or a direct dial. In our case, we're going to create a secure VPN tunnel over the internet. And then we'll give it our IP address. In my case, it's 198.10.20.12. And I'll give it a name. Let's call it the corporate VPN. And then from there, we're going to hit next. We have to put in our username and our password. So let's say it was jason.dion and my password of password. And then we can hit connect. And there you go. You're now connected to the VPN, and you can see that we have an access over our VPN connection, and we have our wireless connectivity on top of that. And that's going to make that secure tunnel so that nobody can see anything that we're transmitting from our laptop over the internet back into our VPN network. Now, once you've decided to use either a site-to-site or a client-to-site VPN, you need to decide one more thing, and that's whether you're going to use a full tunnel or a split tunnel VPN configuration. Now, both full tunnel and split tunnel VPNs can be used with either a site-to-site or a client-to-site VPN, and each one gives you different abilities. Now, a full tunnel VPN is usually what's going to be used by most organizations by default, and it's what I described earlier. With a full tunnel VPN, we're going to route and encrypt all of our network requests through the VPN connection back to the headquarters, regardless of where that destination or the service is actually going to be located. This is considered to be more secure, but when you're connected using a full tunnel, all of your clients are considered to be fully a part of your headquarters network whenever they're connected. This means that if you're trying to access a local area network resource, like a wireless printer in your home office, you're not going to be able to do that because that wireless printer in your home office is not connected back to your headquarters network like your laptop is because you're using that client-to-site VPN connection. Conversely, though, you can still print to the printer in your headquarters office when you're connected using that full tunnel VPN because all of your headquarters resources are still virtually connected to you, even if you're sitting in a hotel room halfway around the world. Now, a split tunnel VPN, on the other hand, is going to divide your traffic and network requests and then route them to the appropriate connection or network. A split tunnel VPN will route and encrypt only the traffic that's bound for your headquarters network over your VPN, and everything else will be sent out a split tunnel to the rest of the internet directly from your location. For example, if I'm using a client-to-site VPN on my laptop using a split tunnel from my home office, I actually have a VPN that's going to decide which traffic will be routed over the VPN and which traffic will go directly over to a website that's located directly on the internet. So if I'm trying to access a file server or a Microsoft Exchange mail server from my corporate network, I'm going to go through the VPN and all those packets will get encrypted and routed back to the headquarters network. But if I'm going to attend a Zoom conference or access Office 365, that traffic that's bound for those will go directly to those sites by going directly through my internet connection and bypassing the headquarters network completely. And this is why we call this a split tunnel configuration, because we have both an encrypted VPN tunnel for the traffic that needs to go to the headquarters and an unencrypted direct internet path or tunnel for everything else that's available openly and online in the public internet. Now, the big challenge when you're using a split tunnel is that these can be less secure because now we have a possibility that an attacker could connect to your device over your unencrypted internet tunnel and then pivot through your laptop and send data back through the VPN over to the headquarters network. For this reason, if you're connecting to the VPN from an untrusted network, like using Wi-Fi at a hotel or a coffee shop, you should always use a full tunnel VPN and not a split tunnel VPN because this gives you higher levels of security. That being said, a split tunnel will give you better performance because it's routing all internet-based traffic directly to those internet servers and bypassing your entire headquarters network. So, as you can see, once again, we have to make a decision and weigh the trade-offs between security and performance when we're choosing which type of VPN tunneling we want to use. For more security, you're going to use a full tunnel VPN. For better performance, you're going to use a split tunnel VPN. So, now that we've talked about two main types of VPNs, a site-to-site VPN and a client-to-site VPN, we need to talk about the third type, and the third type is known as a clientless VPN. Now, a clientless VPN is going to be used to secure remote access VPN tunnels using a web browser, and it doesn't require any software or hardware clients to be configured. In fact, you use this VPN every single day without even knowing it. A clientless VPN is going to be used by your web browser when it makes a secure connection to an e-commerce or other secure website using the HTTPS connection over port 443, and it uses a TLS protocol to encrypt the data being sent to and from that website. Now, TLS, or the Transport Layer Security Protocol, is going to provide cryptographic and reliability using the upper layers of the OSI model, specifically layers 5, 6, and 7. So if you logged into this website to watch the video, you had to actually enter your username and password. And when you did that, you looked up to verify there was that little green lock in the upper left corner of the address bar. If you saw that, you knew you had a secure HTTPS connection and that you're using TLS to create a secure clientless VPN tunnel through your web browser from your computer over to my server to be able to log in securely without your username and password being sent directly over the internet without being first encrypted. This now allows you to watch these videos over the secure and encrypted tunnel between your system and my system. TLS uses the Transmission Control Protocol, which is known as TCP, for us to be able to establish our secure connections between a client and a server. But this can slow down your connection because TCP has a lot more overhead than a UDP connection does. So, your systems can also opt to use DTLS instead. And DTLS is the Datagram Transport Layer Security Protocol, which is a UDP-based version of the TLS protocol. DTLS does provide the same level of security as TLS, but it operates a bit faster because it has less overhead in the UDP protocol itself. Now, DTLS is considered to be an excellent choice to use when you're wanting to provide video streaming and things like that over a secure and encrypted tunnel. This provides the end user with security over a UDP connection and prevents eavesdropping, tampering, and message forgery inside of our clientless VPN connections. Now, in most modern VPNs that rely on site-to-site or client-to-site connections, though, you're going to see that we're going to use the Internet Protocol Security Suite, which is more commonly called IPsec, instead of using a clientless TLS encrypted tunnel. In fact, IPsec is the most popular protocol in use today for the creation and operation of VPNs because it provides us with confidentiality, integrity, authentication, and anti-replay protections when we're using our VPN connections for both site-to-site and client-to-site VPNs. IPsec is a secure network protocol suite that provides authentication and encryption of our data packets to create a secure encrypted communication path between two computers over an internet protocol network. IPsec provides confidentiality by using data encryption. IPsec will also provide us with the integrity that we want by ensuring that our data was not modified in transit by checking its hash digest before it's transmitted and then again once it's been received to ensure they match. Authentication is going to be provided by having each party verify they are who they claim to be, and IPsec will also provide you with anti-replaying by checking the sequence of numbers on all of the packets before they're sent. This prevents the transmission of any duplicate packets, and it prevents an attacker from being able to capture and resend packets later as part of an attack. Now, there are 5 main steps in the process of establishing and using a secure VPN tunnel when you're using IPsec. First, there's a request to start a key exchange. Second, IKE Phase 1 is going to authenticate the parties and establish a secure channel for negotiation. Third, IKE Phase 2 is going to negotiate the security association parameters and fully establish the secure tunnel. Fourth, we're going to have data transfer, and this is then going to allow data transfer between the two parties to occur over the secure tunnel using the IPsec parameters and keys that we stored from the security associations that were negotiated back in Step 3. And fifth, IPsec tunnel termination is going to occur, and this happens when the security associations are going to be terminated through either a mutual agreement and deletion or due to the timing out of the tunnel because one party became non-responsive. Now let's take a look at these 5 steps and how they work in the real world. First, I have PC1, and they want to be able to send some traffic over to PC2. To do this, Router 1 is going to create an initiation of an IPsec tunnel. Second, we're going to see Router 1 and Router 2, and they're going to start negotiating the security associations to form the IPsec IKE Phase 1 tunnel. This is known as our ISAKMP tunnel, or ISA-KMP. Now in Step 3, IKE Phase 2 is going to create this tunnel inside of a tunnel when it's negotiated and set up. Now once this second tunnel is established, we can then begin to conduct data transfer in Step 4, and the information will start flowing between PC1 and PC2 securely. When they're all done with that, we reach Step 5, and the tunnel will be torn down, and the IPsec security associations are going to be deleted. Now, if you want to be able to create another VPN, you can do that by starting this whole process over again from the beginning and going through those 5 steps once more. Now, to allow the data transfer to happen inside of IPsec, we do this during Step 4, and we're going to do this using one of 2 modes. These modes are known as transport mode or tunneling mode. First, we have transport mode, and transport mode is going to use the packet's original IP header, and it's going to be used for client-to-site VPNs. The transport mode approach works really well if you have problems increasing your packet size because you may go over your maximum transmission unit size, or MTU, inside of your network. Remember, by default in most networks, the MTU, or maximum transmission unit size, is going to be set at 1500 bytes in most of our networks. If you go over 1500 bytes, that packet will become fragmented, and this can cause issues with your VPN's functionality. If you're using a client-to-site VPN, I highly recommend that you use a transport mode as your IPsec method because it doesn't add any additional padding to your packet and it doesn't increase its size. Now, on the other hand, if you're setting up a site-to-site VPN, like having a regional office connecting back to your main office, then I would use tunneling. Now, tunneling mode is going to be used to encapsulate the entire packet and put another header on top of it. This will increase the size of the packet, and this could cause you to go over that 1500 bytes of your MTU, or maximum transmission unit size. Now, when you think about tunneling mode, I want you to think about it this way. Let's say you have a letter that you want to deliver, and you put it in an envelope. Inside of that envelope, you're going to put down the address of who you want to send it to. Now, before you send it out, you're actually going to tunnel it by putting it into a second envelope and putting a different address on it. Now, when you put that second address on it, this is going to be a new header, and this new header has the new source and destination of the VPN terminating device at the different site that you want this letter to go to. When it gets to the other side, your VPN concentrator will remove the outer envelope, which is that outer header, and inside of that will be the network packet that can be decrypted and then routed across their private local area network, just as if it came from an internally connected client. When you're using this tunneling mode, you're actually encapsulating the entire packet into a new packet so you can send it over the public internet. This is going to increase the size of your overall packet, and it could go above the MTU default size of 1500 bytes. So if you're going to be using a site-to-site VPN, you may need to allow jumbo frames, or frames that are bigger than 1500 bytes, inside of your network to be able to access this type of tunneling mode. This way, it'll be able to properly support these packets that are larger than 1500 bytes. Now, if you can't set up jumbo mode, another way you can do this is by actually dropping the maximum MTU size on your inner router to something like 1400 bytes and then connecting to the VPN. This way, you've got an extra 100 bytes of room between 1400 and 1500 bytes to be able to add that extra encapsulation and the new packet header before it's transmitted over the public internet inside of your VPN tunnel. If you control your entire network, though, you can again just use jumbo frames and actually go up to a size of up to 9,000 bytes if you wanted to. But this should only be done on your own local area networks because 9,000 byte packets will have trouble transversing the entire internet. Now, the final thing we need to discuss in this lesson is the concept of an AH or authentication header, as well as an encapsulating security payload or ESP that is used within your IPsec protocol. Now, the AH or authentication header is going to be used to provide connectionless data integrity and data origin authentication for IP datagrams, and it provides protection against replay attacks. Be aware, though, that the authentication header does not provide any kind of confidentiality of the data itself. Instead, the authentication header contains a cryptographic hash of the data, and this will simply act as identification information to provide the integrity between the sender and the receiver of each packet that's being transmitted. Now, the encapsulating security payload, or ESP, on the other hand, is going to be used to provide authentication, integrity, replay protection, and confidentiality of your data. By using ESP within IPsec, you can actually rewrite the payload of the packet inside of an encrypted format. Now, when we're using ESP, we're only protecting the confidentiality of the payload that's contained within the packet, not the headers themselves. So, if you're using transport mode, such as in a client-to-site VPN, you can use authentication headers to provide integrity for your TCP header, and then you can add ESP, or the encapsulating security payload, to be able to encrypt the TCP header and the data inside the payload. This does not encrypt the end-to-end header, so people outside your organization, though, will be able to see where the data is coming from and where it's going to, but they won't be able to read the data inside. It's just like if I went to your mailbox and looked at a letter in there. I could see who sent you the letter, and I could see that it was sent to you, but I don't know what's inside that letter because I haven't opened up the envelope. Now, if you're using the tunneling mode, such as in a site-to-site VPN, you can instead use both the authentication header and the encapsulated security payload to provide integrity and encryption of that payload, including the end-to-end header. In this case, a new IP header is going to be added to the front of the packet to cover the hops to the other end of the secure connection. This means that nobody on the internet will be able to see the source or destination of the traffic within your organization's internal networks on either side of that VPN connection. So remember, when it comes to securing network communications, we usually rely on a VPN, TLS, or IPsec to ensure the data remains safe from prying eyes as it traverses over an untrusted or insecure network like the internet. A VPN, or virtual private network, is a secure and encrypted connection between a user's device and a remote server that allows for private and anonymous access to the internet. A client-to-site VPN will allow individual users to remotely connect to a secure network, while a site-to-site VPN establishes a secure connection between two separate network locations. A clientless VPN is a remote access solution that's going to allow users to securely access network resources using a web browser without the need for a dedicated piece of client software that's going to rely on the Transport Layer Security Protocol for its encryption. IPsec, or the Internet Protocol Security Suite, is a suite of protocols that's used to secure Internet Protocol communications by authenticating and encrypting each IP packet in the data stream. IPsec can be configured to use either transport mode or tunneling mode. Transport mode is normally going to be used for client-to-site VPNs, while tunneling mode is normally going to be used for site-to-site VPNs. These different tools and protocols are going to be used to help encrypt our data and to protect it against any potential eavesdropping or modifications as it transits across the internet and other insecure networks.